Hello, today's lesson will be lesson 2.1a. So let's get started. I'll share my screen and close this out here, and we will press present. I will minimize myself so you can see the screen. Okay, like I said, this is lesson 2.1a. Today we're going to be talking about the greatest common factor, something that you may have done last year in 5th grade. If not, you will learn it this year. The standards you're going to be covering is I can understand common factors and I can find the greatest common factor. The actual standard is NS4. We're going to do the first part today. Find the greatest common factor of two whole numbers less than or equal to 100. And then in our next lessons, we're going to talk about the least common multiple and the distributive property mentioned in this standard here at the bottom. So today we're just focusing on greatest common factor. So finding the GCF, also known as the greatest common factor, is easier than I thought. Hopefully you will be able to say that at the end of this lesson. So we need some definitions. So let's start with a factor. Since we're finding the greatest common factor, we have to know what a factor is. A factor is a number that divides into another number exactly and without leaving a remainder. So if we were to do this division, I want to go back one. Let's do our division here. And my little bar disappeared, so I'm going to add my bar back here. All is not perfect in the world sometimes, so here we go. Let's put our bar there. Okay, how do you divide 2 into 64? Well, you're going to divide 2 into 6, right? So I always use the phrase, does McDonald's serve burgers? I'm actually going to put that up here. Does McDonald's serve burgers? What on earth does that mean? What does McDonald's have to do with a math problem, Mrs. Claus? Well, the does stands for divide. So the first thing I'm going to do is divide my 2 into 6. 2 goes into 6 3 times, so I'm going to write my 3 over my 6. Then I go to McDonald's, multiply. 2 times 3 is 6, so I'm going to put that right here. Then I'm going to go to serve. That stands for subtract. I'm going to subtract 6 minus 6, and I'm going to get 0. And then burgers stands for bring down. I'm going to bring down the next number, which happens to be a 4. I'm going to draw a little arrow to show that I'm bringing down the 4. And then I repeat again, does McDonald's serve burgers? Does, divide. 2 divided by 4, or 4 divided by 2, I should say, is 2. McDonald's multiply. 2 times 2 is 4. Serve is subtract. 4 minus 4 is 0, and burgers is bring down. Well, there's nothing here to bring down. I am finished. I have a remainder of, what's my remainder? My remainder is 0. Remainder equals 0, right? So I can say that 2, let me circle those. I can say that the number 2 and the number 32 are both factors of 64 because 2 times 32 gives me 64. And now we'll bring the yellow box down. When 2 is divided into 64, there is no remainder. Therefore, both 2 and 32 are factors of 64. They multiply together to give you exactly 64. Can you think of other factors? How about 2 times 4 are factors of 8. How about 3 times 4 are factors of 12? So that's what a factor is. Now let's talk about the word common. What does it mean if something is common? Something that is the same between 2 or more things. So for example, if I like to play video games and my friend likes to play video games, then we have something in common. We both like to play video games. So video game playing is what we have in common. So now let's take that into math. What is a common factor? Now that you know what common means and you know what factor means, what do you suppose common factor means? Right, it is when two different numbers share the same common number, the same factor that exactly divides into both of the numbers without a remainder, that number that evenly divides into both numbers is a common factor. So for example, if I had 3 times 3 equals 9, and I also had 3 times 4 equals 12, the factors of 9 and 12 that are the same, that are common, would be what numbers? 3 is a factor of 9, and 3 is a factor of 12. So the common factor would be 3. Okay, let's go on. We'll get to practice that a little bit in a minute. So let's find the common factors. So we're going to find the common factors of both 18 and 30. So step 1 is to list all the factors of each number. Here's where we can't forget any. So we have 18 and 30, and we want to list the common factors. First, we want to list all the factors. So 1 times 18 will give you 18. 3 times 6 will give you 18, and 2 times 9 will give you 18. There are no other numbers that you can multiply together to give you 18. So we found them all. So we're going to list them in order. 1, 2, 3, 6, 9, and 18. That's just these numbers on the left, and I put them in order from smallest to biggest. Okay, what about 30? Well, 1 times 30 is equal to 30, right? Can you think of any others? 2 times 15, 3 times 10. Are there more? Well, let's take a look. 1 times 30, there it is. 2 times 15 is there. 3 times 10, and look at, did you forget 5 times 6? 5 times 6 equals 32, doesn't it? So now we're going to list them in order on the right there. 1, 2, 3, 5, 6, 10, 15, and 30 are all factors of 30. Now our goal is to, step 2, probably the next slide here, we're going to list all the common factors of both. So step 2 is to circle all the factors that are common or the same in both numbers. Let's put them back up there again. There were our factors that we found on the previous slide. So which ones are the same? Well, we're going to go ahead and circle them. There's a 1 in 18 and a 1 in 30. There's a 2 in 18 and a 2 in 30. What else? There's 3 in 18 and a 3 in 30. What else? A 6, and that's it, right? Nothing else is common. There's only a 5 in the 30, not the 18. There's only a 9 in the 18, not the 30, etc. So those are the only numbers that are common to both numbers. The common factors are 1, 2, 3, and 6. So far, so good? Let's move on. Another definition, we have to find the greatest common factor. Well, we found all the common factors. Which one is the greatest? Let's bring back our thing. The greatest common factor of two numbers is the greatest factor shared by those numbers. So here we are. We found the common factors of 18 and 30. Now we're going to find the greatest common factor. So let's go back and list them. Find the greatest common factor, or the greatest number from our common factor list. That's step 3. So there we have our circled common factors again. 1, 2, 3, and 6. There they are listed in the blue box. Which one is the greatest? Which one is the biggest? Which one is the largest? I hope you're all saying 6 out there in virtual land, because 6 is the greatest number of those common factors. So 6 is the greatest common factor. 6 is the greatest common factor, also abbreviated the GCF of both 18 and 30. Okay, here are the steps again. Step 1, list all the factors of each number. Don't forget any. Step 2, circle all the factors that are common to both numbers, that are the same in both numbers. and 3. Find the greatest number from our common factor list. This method is called the list the factors method. I'm actually going to be showing you another method as well, so you can pick between the two. Okay, we're going to find the greatest common factor of 14 and 35. Step 1, now we're doing the list the common factors method. So step 1, we're going to list all the factors of each number. All the factors of 14 and all the factors of 35. So pause the video, see if you can come up with all the factors of 14 and then list all the factors of 35 and then come back and check with me to see if you got it right. Okay, hopefully you pause the video. Here's the 14. 1 times 14 and 2 times 7 are the common are the factors of 14, not the common ones, the factors. List them in numerical order, 1, 2, 7, and 14. Did you get 35 now? 1 times 35 and 5 times 7. I don't know if there's any more. Could there be another one? How about 2 times, I don't think so. Let's just see, 17 times 2. No, that's not it. That's 34. So that's it. I'm going to put those in order, 1, 5, 7, and 35. Now step 2, circle all the factors that are common to both numbers. Now we're going to be looking over here in our list. Which ones are the same in both numbers? I hope you're saying 1, and I hope you're saying 7. That's the only 2 factors that are common to both 14 and 35. Step 3 then is to find the greatest number from our common factor list. So the greatest common factor. So the common factors again are 1 and 7. That's in the blue box. The greatest one is, drum roll, exactly, it's the 7. The 7 is the greatest common factor. What that means is that 7 will divide into 14 without a remainder, and 7 will divide into 35 without a remainder. 7 is the greatest common factor of both 14 and 35. Okay, let's have you give this a try. See if you can find the greatest common factor. Okay, welcome back. I'm sure you did well on that. Let's move on. Factor trees can be helpful when finding the greatest common factor for big numbers. I'm going to show you another method that you can use. So we're going to find the greatest common factor of 18 and 30 again. That was our first example that we did on the first couple of slides. So this time we're going to use a factor tree, however. So we have 18 and we have 30. Now why do they call it a tree? Because it kind of starts resembling like a Christmas tree. So we're going to put a line for the 18 and we're going to think of 2 factors that multiply together to give you 18. Well, I'm going to say 2 times 9 because that comes to my head pretty quickly. It doesn't matter if you pick 3 times 6, you'll still end up with the same answer. But let's do 2 times 9. 2 times 9 is 18. So I'm going to put the 2 on the first branch and the 9 on the second branch. Now I'm going to say, okay, well, this 2 here can't be divided any further. The only thing that'll work with 2 is 2 times 1, right? So we're not going to go any further. 2 is considered prime. A prime number only has the factor of itself and 1 as the only other factor. But 9 over here does have more factors. Can you think of what they are? Exactly. We can divide 9 further into 3 times 3. And now 3 is prime, and this 3 is prime because there's no other number I can multiply by 3 except 3 times 1. Now I'm going to circle all the prime numbers, all the factors that can't get divided any further. So just the 2, the 3, and the 3. I'm not going to circle the 9 because that was divided further, and I'm certainly not going to circle the 18 because that can be divided a lot further. Now I'm going to do the same thing for the 30. What 2 numbers multiply together to give you 30? Well, you have several to pick from. I'm going to pick 3 times 10. You could just as easily pick 2 times 15 or 5 times 6. You will end up with the same answers. So we're going to make our tree. 3 times 10. Now I already see that this 3 is as far as I can split it. I can't come up with anything else multiplied together to give me 3 except for 1 and 3. So that 3 is prime. But 10 over here I can split. Right, I can do 2 times 5. So I'm going to split that into 2 times 5. Now you'll notice that 2 cannot be split any further and 5 cannot be split any further. So I'm going to circle all the numbers that are prime. The 3 is prime, the 2 is prime, and the 5 is prime. Okay, so far so good. Now I'm going to circle the ones that are common to both 18 and 30, the prime factors that are common to both. Will I see a 2 in red that I circled by the 18 and a 2 by the 30? They're both the same. You find another common prime factor? Yes, a 3. They each have a 3. And the last set here is a 3 and a 5, and they're not the same. So we can only do a 2 and a 3. So I'm going to list them there at the bottom. 18's prime factors are 2 times 3 times another 3 in blue. And 30's factors are 2 times 3 times 5. And then we're going to circle the ones that are common to both, the 2 and the 2 and the 3 and the 3. So now I'm going to multiply just the common factors together. So I have a common 2 over here and a common 3. So 2 times 3 is equal to 6. So 6 is the greatest common factor of 18 and 30. And if you go back to the first couple slides, we already found that 6 worked with our first method, our list the factors method. And 6 is also working with this method, which is called our prime factorization method. This is called the prime factorization method because we're finding all of the prime numbers. Prime meaning the numbers that won't divide any further. So let's try this again. My 2 shouldn't be showing up at the bottom there, but that's okay. Say we are going to use the prime factorization method to find the greatest common factor of 56 and 64. So we're going to put 56 and 64 there, and then we're going to make our tree. So we're going to start with 56. 7 times 8 is 56. You may have thought of 2 other numbers. That's fine. You get to the same answer in the end. I see that 7 is as far as that will go. It is prime. Nothing more will multiply together to give me 7 other than 7 times 1. So let's see about 8. I can do what with 8? 2 times 4, right? But now I have 2 that's prime, right? But I can split the 4 further. So I'm going to keep going. The 4 is going to become 2 times 2. Supposed to be a little times in between there. So now I've got all my prime factors of 56. 7 is prime, 2 is prime, another 2 is prime, and finally a last 2 is prime. I'm going to do the same thing now with 64. I'm going to use 8 times 8 is 64. You could easily pick something else. You could do 2 times 32 if you wanted. I'm doing 8 times 8. And I know I can split 8 further. I can split 8 into 2 times 4. Well, now that I've done that, 2 is prime, but I'm going to split my 4 up into 2 times 2, right? So now I've got 3 2's there. Now I got to go back over here and do this other 8 and split that one up. So I'm going to do 2 times 4 over here, and I'm going to further split my 4 into 2 times 2. Now I'm going to circle all my prime factors, the ones that can't divide any further. So which ones am I going to circle? All right, I'm going to circle a 2, a 2, and a 2. And I'm also going to circle a 2, a 2, and a 2. Wow, that 64 has a lot of prime factors, and they're all 2's. Look at that. So now I'm going to circle what's common to both. There's a 2 in 56 and a 2, where the rest of them are. There they come. There's a 2, a 2, and a 2 in 56 and 64. 3 2's in each. So there they are listed. 56 is 2 times 2 times 2 times 7, and 64 is 2 times 2 times 2 times 2 times 2 times 2. So if you were to multiply that with a calculator, if you multiplied all those 2's together, you would get 64. And if you multiplied 2 times 2 times 2 times 7, you would get 56. Now, which ones are common to both? The 2's, and another pair of 2's, and a third pair of 2's. We have no more matches, do we? This one here has a 7, and it's going to be hard to see because that black bar is going to show up. That one there has a 7, and below it is a 2. So there's no other 2's to match, and there's no 7's to match with both numbers. So our prime factorization method says that we have 3 2's that are common. So let's bring those down. So now we're going to multiply those 3 2's together. 2 times 2 times 2 is equal to 8. So 8 is the greatest common factor of 56 and 64. Okay? Let me clear my little X there. So let's compare the methods for a second. So let's find the greatest common factor of 30 and 54. 30 and 54. So we're going to use the list the factors method first. That's the one you already tried on your practice question. So step 1 is to list all the factors of each number. So we're going to list all the factors of 30 and all the factors of 54. So pause the video, see if you can list all the factors of 30 and all the factors of 54. And then if you want to go ahead and find the common factors and then see if you can find the greatest common factor, then come back to the video and see if you've got it right. Okay, all the factors of 30 are 1 times 30, 2 times 15, 3 times 10, and 5 times 6. There are no others. So we list them in order: 1, 2, 3, 5, 6, 10, 15, and 30. We're going to do the same for 54. Hopefully you did this. 1 times 54. Never forget the 1 times the number 1. That all counts. 2 times 27. Did you get that one? That one's a harder one. 3 times 18. That's also a harder one. And 6 times 9. We're going to list them in order: 1, 2, 3, 6, 9, 18, 27, and 54. Step 2, circle all the factors that are common to both numbers. Well, what's the same between these two numbers here? The 1's are the same, the 2's are the same, the 3's are the same, and the 6's are the same. I think that's it, right? And then the third step is we're going to find the greatest common factor. Find the greatest number from our common factor list. Well, here's our common factor list. 1, 2, 3, and 6, the ones we circled in red. Which one is the greatest? Exactly, 6 is the greatest common factor of 30 and 54. What does that mean? That means that I can divide 6 into 30 evenly without a remainder, and I can divide 6 into 54 evenly without a remainder. Now let's compare that to the prime factorization method. Why would you want to use that method instead? Well, if you look, when you did 54, it may have been hard for you to think of 2 times 27 and 3 times 18 as being factors in that 54. So the prime factorization method can be easier when you have bigger numbers like a 54. So let's take a look at it. Oh, 6 is the greatest common factor. We already know that. Let's go on. So this is the prime factorization method. We're going to make our trees. We're going to find the greatest common factor of 30 and 54 using the second method now. Step 1 is to make our factor tree. So we got to put 30 and 54 out there. And then we're going to start subdividing 30. We're going to pick two numbers. Something times something gives us 30. We got several to pick from. I believe I picked 3 times 10. Yes, I did. You could easily have picked 5 times 6 or 2 times 15. You get the same answer in the end. Try that if you want to pause the video and try it with another set of numbers. Okay, 3 times 10. I know that 3 is as far as that one will go. So that's going to be circled. That's going to be prime. How about 10? I'm going to subdivide 10 into 2 times 5. Now I've found all the prime factors because 3, 2, and 5 cannot be subdivided any further. So step 2 is to circle all prime factors. So I'm going to circle 3. I'm going to circle 2. and I'm going to circle 5. Those are the prime factors of 30. I'm going to do the same exact thing with 54. I'm going to make my factor tree, and I believe I picked 6 times 9 for 54, and I'm going to split both of those up further. I'm going to split 6 into what? Yes, 2 times 3, and both 2 and 3 now are prime. They can't be split any further, but I can still split the 9. I can't forget about that one. 9 will split by 3 times 3. And now 3 and 3 are also prime. So now I'm going to do step 2, circle all my prime factors. I'm circling a 2, I'm circling a 3, I'm circling another 3, and I'm circling another 3. Okay, step 3 then is going to be circle all the common prime factors to both numbers. Got to find numbers that are the same in both 30 and 54 out of the circled blue numbers. Well, I see that there is a 3 and a 2 in both the 30 and the 54. So here we are. There's the 30, 2 times 3 times 5, and there's the 54, 2 times 3 times 3 times 3, and I can only circle a 2 and a 3. So now my step 4 is to multiply the common factors together. Multiply the common factors to get your GCF. So 2 times 3 is equal to 6. So how did I get 8? 2 times 3 times 3 times 3. 2 times 3 times 5. Multiply the common factors to get 8. Oh, it should be 6. Should be not 8. Should be 6. What am I saying? We decided it was 6 on the last one. Cross that off. Let's see. Let me get my black marker. I must have forgot to change it from the last one. Put an X through that. It's 6. So 6 is the greatest common factor of 30 and 54. 2 times 3 is 6, not 8. 6. Okay, let's clear it. Comparing the methods. List the factors method. Step 1, list all the factors of each number. Step 2, circle all the factors that are common to both numbers. Step 3, find the greatest number from our common factor list. Prime factorization method, which works great when you have great big numbers and you can't think of all the factors. Step 1, make a factor tree. Step 2, circle all the prime factors once you've made your factor tree. 3, circle all the common prime factors to both numbers. And one more step, multiply the common factors together. This is your GCF. Either method will get you to the greatest common factor. Okay, it's your turn to give the prime factorization method a try. Okay, welcome back. Let's talk about a little higher order thinking before we end our lesson for today. How can you find the greatest common factor of 3 numbers? We've done 2 numbers, but we've never done 3. So let's find the greatest common factor of 81, 108, and 36. So we can use both methods. We're going to list the factors method and the prime factorization method. So let's start with the list the factors method. So 81, we've got to think of all the numbers that multiply together to give us 81. Well, 1 times 81, I can always start with that, can't I? 2 will not work because 81 is not an even number, but 3 will work. 3 times what, though, gives me 81. What can I, if I don't know, what can I do? Well, I can do this. I can divide 81 by 3 and see what I get. So 3 times 2 is 6. That's as close as I can get to 8 without going over. Does McDonald's serve, subtract? 8 from 6 is 2. Bring down burgers, the 1. 3 goes into 21 7 times. 3 times 7 is 21. 21 minus 21 will give me 0. So 3 times 27, that's one that you may not know. That's why the prime factorization method can actually be very helpful. Are there any other numbers? 4 isn't going to go into there, is it? Nope. 5 isn't going to go into there. 6 doesn't go into there. 7, No, 8, no. How about 9 times 9? That's the other factor, so I'm going to erase my division here. So 9 times 9 is the only other factor that I can come up with. So now I'm going to list those over here. We got, put them in order now. 1, we got 3, we got 9. There's 2 9s, right? But we're only going to list it once. And then we've got 27. Okay. Now 108, we got to do the same thing with 108. So we can start with the big one. 1 times 108. That will always work, won't it? Okay, and I know that 2 is going to work because 8 is an even number. So let's do that division real quick. We don't know off the top of our head. 2 times what gives me 108? Let's divide and see. So we're going to take 2 into 10. It's going to go exactly 5 times. 2 times 5 is 10. 10 minus 10 is 0. We're going to bring down our 8. Now we're going to do it again. Does McDonald's serve burgers? Does 2 divides into 8 4 times? We're going to multiply. 2 times 4 is 8. We're going to subtract. 8 minus 8 is 0. There's nothing more to bring down, so we are done, which is good because I'm at the bottom of my page there. So we can say 2 times 54 also works. So let me erase this so we can put 2 times 54 there now. So 2 times 54. And I also know that 3 will work. You may not know that, but I know that. You know how I know that? Because if you add up the digits in the number, 1 plus 0 plus 8, you get 9. If the sum is divisible by 3, the whole number is divisible by 3. So we know 3 is going to work. So 3 times something. So let's do our long division again. 108 divided by 3. Well, 3 times 3 is 9. That's as close as we're going to get to 10. 10 minus 9 is 1. We're going to bring down the 8, 18. 3 times 6 is 18. And then we would keep dividing and get subtracting, and we'd get a 0 at the bottom. So 3 times 36. Are there others? There sure is. Let's erase this again so we have more room again. Okay, what about 4? I happen to know that 4 will work. Why? Because the last number 8 is divisible by 4. So I know that 108 is divisible by 4. So if I don't know what that is, I'm going to redo my division. Do you see how the prime factorization method can actually save you more time? So let's just keep doing the list of factors method. 4 goes into 10 twice. 2 times 4 is 8. 10 minus 8 is 2. Bring down the 8. 4 times 7 is 28, and then I would subtract, and I'm going to get a remainder of 0. So 4 times 27. I'm going to erase that again so I have more room. 5 will not work because it only works with 5 if you have an ending number of 0 or 5. What about 6? Will 6 work? 108 divided by 6? Well, I encourage you to give it a try. It does work. So let's move that black box. Here we go. 6 times, we don't know yet, so we have to do this again. 108 divided by 6 this time. So let's put a 6 there. 6 goes into 10 only one time. I'm going to subtract 10 minus 6 and get 4. We're going to bring down our 8. 6 goes into 48 8 times. 6 times 8 is 48, right? 48 minus 48 is going to give us 0. So 6 times 18 will give you 108. Are there any others? Can you think of more? How about 7? 7 will not work. How about 8? Will 8 work? Nope, 8 doesn't. 8 will give you a remainder. What about 9? Does that work? Yep, 9's going to work. Okay, we better figure that out. Erase this so we can do the 9 now. Okay, so we got 108. And we got the 9 here. So we're going to do 9 times something here. Okay, 9 goes into 10 one time. 10 minus 9 is 1. We're going to bring down our 8. 9 goes into 18 twice. 2 times 9 is 18. 18 minus 18 is 0. So 9 times 12 is also going to work. Will 10 work? No, because it'll only work if it ends in a 0, right? What about 12? Will 12 work? Yeah, 12 is going to work too, but we already have it here, don't we? We have 12, 9 times 12. So I believe we've come up with all of them. I'm going to erase my division here again. 13 won't work. 14 is not going to work. 15 is not going to work. 16 is not going to work. So we have found them all, I believe. So let's list them here. We have 1, put them in order. We have 2, we have 3, we have 4, we have 6, we have 9, we have 12. See if I'm not missing any here. 18, 27, and the last one, if I can squeeze it in there, oh no, 2 more. 54, I'm going to put it down here. 54 and 108. That's all the factors of 108. Now I have to do that for 36. So let's put 36 down here and see if we can squeeze that in. Well, we'll start with 1 times 36. There's not as many for 36. 2 times what? Well, if you don't know, you can divide 36 by 2. I'm going to just tell you it's 2 times 1, 2 times 18. Yes. And 3 will also go into there. How many times? You got that? If you don't know, you can divide using the long division that we did with the 108. That would become 12, right? And 4 times 9 is 36. 5 won't work. The last that'll work is 6 times 6. And then we're coming back to 8 doesn't work. 9 is this. Now when we get to 9, it's 4 times 9 is already there. So we're good. So let's list them in order. 1, 2. So you see how this prime factorization method that we're going to do second is going to be actually easier than the method we're using right now. But let's just see how this works. 1, 3, 4, 6. Tell me if I'm missing any. 12. Oh, got 9. 9, 12, 18, right? And 36. I hope I didn't miss any in my order here that I put. And 1, 2, 3, 4, 6, 9, 12, 30, 18, 36. Okay. Phew. Now what do we have to do? Now we have to find all of the common factors. So let's circle all the common factors, but they have to be common factors to all 3 numbers now, to 81, 108, and 36. Well, I can use 1. That'll work for sure, right? How about 2? Well, I have a 2 in 2 of them, but not the 3rd one, right? So that won't work. How about 3? Yep, there's a 3 here, a 3 here, and a 3 in this one. How about 4? Well, there's no 4 in the top one, so that's not going to work. How about 6? It's in 2 of them, but not the top one. How about 9? Yes, 9's in all of them, so let's circle the 9. Okay, how about 12? It's only in 2 of them, right? How about 18? That's only in 2. How about 27? That's in 2 of them, but not the 3rd one, is it? And then 36 is only in 1 of them. So that's all of the common factors. Now I have to find the largest common factor. So I'm going to actually erase the left side here. So I have a little bit more room because we have all the factors listed on the right side now anyhow. So it's the same thing, just listing them without the times sign in between them. Erase all of that. There we go. So let's list all of the factors. We have a 1, we have a 3, we have a 9, and that's it, right? A 1, a 3, and a 9. Okay, so which one is the greatest common factor? Exactly, the 9 is the biggest. So we know that 9 will evenly divide into 81, it will evenly divide into 108, and it will evenly divide into 36. It is the biggest number that fits in all three of those numbers without a remainder. That is the list the factors method. So I'm going to put our 9 up here so we can remember what our answer is. And I'm going to erase the screen, and we're going to use the prime factorization method to find the greatest common factor for 81, 108, and 36. Okay, all right, here we go. So we're going to make our factor tree for 81. So I'm going to use 9 times 9 is 81. That's the easiest one for me in my head to remember. 9 times 9 is 81. I can further divide the 9 into 3 times 3, and the other 9 into 3 times 3. Okay, I'm going to go right ahead now and circle my prime numbers. So 3 can't be divided any further, it's prime. This 3 can't be divided any further. This 3 and that 3. Okay, now I'm going to go ahead and do this for 108. So I'm going to write 108 here, 108. And I got to think of two numbers that divide to give me 108. So for me, the easiest to do is 2 times something. So I'm going to do 2 times 54. You could easily start with any of those other ones we found, but let's do 2 times 54. For me, that's pretty easy. 2 is as far as it'll go. I can't divide it any further, so now I'm going to go to 54. Well, 6 times 9 is 54, right? 6 times 9 is 54. So now I'm going to further divide my 6 into 2 times 3. And a lot of students actually find this method to be really fun after they get used to it. It's 2 times 3. And that's as far as 2 and 3 will go. And then 9 will go to 3 times 3. Now I'm going to go ahead and circle all my prime factors that can't divide any further. So I've got 2. Don't forget about that guy up there by himself. Another 2, a 3, a 3, and a 3. Okay? And now I have to do the same thing for 36. That's not as big of one. I can just squeeze it in down here, make our little factor tree. I'm going to use 6 times 6 because I know that one off the top of my head. 6 times 6 is 36. You could easily do 4 times 9 if you wanted to. So 6 times 6 will further divide into 2 times 3, right? Because 2 times 3 is 6. And this other lovely 6 over here will also divide into 2 times 3. Now I circle my prime factors. What are my prime factors? The numbers that can't divide any further, right? So we have a 2, a 3, a 2, and a 3. Okay, now we have to find what's common to all three of them. I'm going to change colors here. So for 81, I'm going to list them here. 81, I've got 4 3s, right? 3, and a 3, and a 3, and a 3. And there would be the little time sign in between, but I guess I'll try to squeeze that in. Okay. For 108, what would those numbers be? What are the red ones that we circled for 108? Well, we circled a 2, we circled another 2, trying to put them in order here, and 3 3s, right? Times 3, times 3, times 3. Hopefully you can see that okay. And then 36, what did we circle? What are the red ones? 2 2s and 2 3s, right? 2 times 2 times 3 times 3. Okay, now we have to find what's common to all three numbers. So let's pick a different color here. So there is a 2 in both of these numbers, but not in the top number, right? So we can't pick any of the 2's. There's a 3 in the 81, there's a 3 in the 108, and there's a 3 in the 36. There's another 3 in the 81 and in the 108 and in the 36. There's more 3's, but there's no more 3's left in the 36 to pair them with. So we are done. That's all that we can do. Now we have to, I'm trying to see where I can do this. Might have to erase something here. So I'm going to just kind of get rid of all this because we did this already now and we see what that is. And just get rid of some of that extra business here. So we have a cleaner screen. And we are going to list all of the prime common factors, right? So we have a 3 in all three numbers and another 3 in all three numbers. That's it. And then our last step is to multiply the prime factors together. 3 times 3 is 9. Now let's compare that to the first method. Go way up here. We got 9 using the list of factors method, and we get 9 using the prime factorization method. So we got the same answer either way. You can decide on your own which way you feel more comfortable with, which way is easier for you. But both methods will give you the same result. Okay, I'm going to clear my drawing and try to move on here to finally. Now what can you say? Finding the GCF is easier than I thought. Can you say this now about yourself? Hopefully you can. I'm going to come back on here. And so your homework is going to be on Google Classroom. I'm not putting it on the screen anymore because sometimes I change my mind. And if I put it on the video, then that's the end of it. It's stuck on the video. So this way you can look on Google Classroom and you can find your homework. So I hope that you have a good day and we will see you for the next lesson. Bye-bye.